Hello guys, this is Wits Lounge, Learning Made Easy, and in this video we are going to be understanding the concept of colloids and suspension.
So, what is a colloidal solution? First of all, I would like you to know that colloidal solutions are also referred to as false solutions. So let's get to the definition. A colloidal solution is a type of mixture in which microscopic insoluble particles are dispersed in another substance. Yes, the major points in this definition is, number one, you have microscopic, meaning that you can't see it with your eyes, and secondly, insoluble. The implication is that it is not dissolved, it is simply dispersed, which means you're going to have two phases, unlike in a homogeneous true solution. With that said, we go into the properties of the colloids. The first property of the colloidal solution is that the particles, colloidal solutions are more or less heterogeneous. You have two phases, they are not one, they are not homogeneous, so you have different phases in a colloidal mixture. So note, colloidal solutions are heterogeneous. The second property is that the particles of the colloidal solutions usually have diameters ranging from 2 to 1000 nanometer. It's small, but relatively a whole lot larger than that of a true solution. Now, because of the relatively large size of the particles of a colloid, you will have that the third property is that it exhibits Tyndall effect. Remember, we said that Tyndall effect is the ability of a particular solution or mixture to distort light, scatter light in different directions, and the emphasis in Tyndall effect is size. Take for instance, you have a toy placed on the road and a particular trailer is passing through that road. What do you think is going to happen? Will the toy somehow distort the direction of the trailer? No, not at all. You will find out that the trailer is going to crush the car and keep moving. Why? The toy is too small, hence no Tyndall effect when you have very, very tiny particles. But when it is relatively large, if you have something like let's say a keke na pepe or a Golf Volkswagen car, you find out that obviously it's going to somehow distort the direction, even though eventually it's going to go through, but there will be a little bit of distortion. So have this in mind, that once you are dealing with a colloidal solution, Tyndall effect is exhibited. There will be a change in the direction of light. But in the case of true solutions, there is no change because the particles of true solutions are very, very small. With that said, we move on to the next concept or the next property. The third property of a colloidal solution is that colloidal solutions cannot be filtered. They cannot be filtered because their particles are very small. They can actually pass through the holes in the filter paper, so you cannot filter colloidal solutions. However, when you tend to pass them through semi-permeable membranes, you could actually have some extractions. So which means that the fifth property of colloidal solutions is that they can be dialyzed. When you pass them through semi-permeable membranes, you are going to have a separation of different substances. The different phases can actually be separated when they are passed through a semi-permeable membrane, like an animal skin or cellophane or something like that. So you notice that colloidal solutions can be dialyzed. So with that said, you would actually see the emphasis or where it comes into play when you talk about your blood dialysis. Yes, blood is a colloidal solution and hence it can be dialyzed. Okay, we go to the sixth property of a colloidal solution. Colloidal solutions are stable. They do not settle. They do not sediment. So when you keep a colloidal solution, you notice that it's not going to settle or sediment. And that's basically about a colloidal solution. Having understood the properties of colloids, it's important to note that there are 4 types of colloidal solutions. Yes, they don't actually have the same properties, so we need to understand that too. So what are the 4 types of colloidal solutions? Number 1, salts and gels. Number 2, aerosols. Number 3, emulsions. And number 4, your foam. So I take them again. The 4 types of colloidal solutions are: number 1, salts and gels; number 2, aerosols; number 3, emulsions; and number 4, foam. So with that said, what is a sol? A sol is a colloidal solution in which solid particles are dispersed in liquid. So when I bring solid and disperse it in liquid, what I get is a sol. If for instance we bring starch and disperse it in water, what I'm going to get is a starch sol. Yes, so you have your starch in water solutions as salts. starch in water solutions are salts. Why? Solid particles dispersed in liquid. Other examples could include the ink mixture, you have your paint, you have your blood. Yes, blood is a salt. You have your glue, agar, gelatin, and other examples. So note, in a salt, you have solid particles dispersed in liquids. So if you noticed, I mentioned the salt and gel together. So what is the gel? Whenever a salt solidifies, you get a gel. I take it again. Whenever the salt solidifies, you get a gel. So the gel is like a solidified salt. You will notice that too, that if you, for instance, happen to let's use a very popular example, the starch solution. If you put starch inside water, eventually it seems as if the starch begins to solidify. So whenever the salt begins to solidify, you get a gel. Blood too, for instance, you notice that blood eventually tends to solidify in form of clots, and then you have that it dries up. When it dries, it looks more solid. What do you call that? A gel. So anytime you have a solidified salt, it is referred to as a gel. With that said, we go to the next type of your colloidal solutions, and that is the aerosol. What is an aerosol? An aerosol is a colloidal solution in which liquid and solid particles are dispersed in gases. Liquid and solid particles are dispersed in gases. So if, for instance, I have sprays from my insecticide cans, yes, those sprays, you do it sprays, and you get what I'm saying. So those guys that come out are dispersed in air, which is a gas. Because the fluid is dispersed in air, you have that mixture at that point is referred to as an aerosol. You have other examples, such as like your sprays from your your deodorant cans, deodorant from your aerosol cans and things like that. With that said, we go to the next example. You have your fog and mist. So I have mentioned three. I said sprays from your insecticide cans, deodorants from your aerosol cans, you have your fog, you have your mist, you have smoke is a solid salt because the particles are dispersed. Solid particles, when you're burning something, tend to be dispersed in air to form what we refer to as a solid aerosol. The third type of colloidal solution we're going to be considering is the emulsion. And what is an emulsion? An emulsion is a colloidal solution in which liquids are dispersed in liquids. Yes, so when you have liquids dispersed in liquids, what you get is an emulsion. Very good examples of that is you have your mayonnaise. You have hair cream. Yes, hair cream is an emulsion. Why? Every constituent that is actually mixed together to form the hair cream, they are all liquids, including the wax. The wax has to be liquefied before it is introduced. So hence you have a mixture of liquids in your hair cream. The third one you could have is the butter. It is an emulsion. You also have your milk. That too is an emulsion. The only paint that we refer to as an emulsion is an emulsion paint. However, paint is more or less classified as a salt rather than an emulsion. With that said, we get into the fourth example. The fourth example of your colloidal solution is the foam. And what is the foam? The foam is a colloidal solution in which gases are dispersed in liquids or solids. Very good examples of that is your whipped cream, your shaving cream, your soap ladder, the soap bubbles. Yeah, all these things are referred to as the foam because gases are actually literally dispersed in the liquids or solids to produce these mixtures. Having said that, we go into the next type of mixture, and that is a suspension. What is a suspension? A suspension is a heterogeneous mixture of two or more macroscopic substances. The emphasis here is that it's heterogeneous, and then you have macroscopic, which means that you can literally see the particles, unlike the colloids where you can't see them. So with that said, we will be considering the examples of your suspensions. What are examples of suspensions? You have your chalk in water solution, you have your mud. That's actually a suspension. Your egusi soup that I earlier mentioned is also a suspension because the particles inside it are macroscopic and it is a heterogeneous mixture. Imagine the large meat and the vegetable and the okporoko. Non-Nigerians might not understand what I'm saying, but that is a suspension. And with that said, we go into the properties of a suspension. Number one, as we all know, it has to be heterogeneous. Number 2 is that the particles are macroscopic. Literally, the particle size of suspensions is relatively about more than 1000 nanometers in diameter. The particles have to be larger than 1000 nanometers in diameter for it to be considered a suspension. Okay, with that said, we go to the third properties. Suspensions settle, they sediment. That is to say, for instance, in Nigeria, here where you fetch those that fetch well water will understand what I'm saying. In parts of Nigeria like Enugu State and stuff, so you get well water, you will notice that the dust particles eventually would settle down if you introduce things like alum. That's because it's a suspension. So you notice that any mixture you have in which constituent particles tend to sediment, once sedimentation occurs, it implies that whatever mixture was there is a suspension. So I take it again. First property is that they are heterogeneous. Second property is that the particles are macroscopic. They sediment or settle whenever they are at rest. The fourth property of suspensions is that they can be filtered. Yes, because the particles are too large, hence they can be separated with a filter paper. So that's that. And then fifth property, which is the final property, is that suspensions are either opaque to light or exhibit single effect depending on the size. So it's either they don't let light pass through at all, or when they let light pass through, they exhibit single effect, which has been described in the earlier parts of the study. With this, I presume you must have learned a lot about mixtures. And with this, we'll be ending this video. Thank you very much for watching. Remember, this is Wits Lounge, learning made easy.